So welcome again friends. Now already we have discussed about how to resolve a force into its two components and how method of resolution can be used to find resultant of concurrent force system. Now let us have a revision about resolution of a force along two perpendicular directions. As we know, the meaning of resolution means dividing a force or splitting a force into its components, and normally we are dividing a force into its two components, one acting along x-axis and second acting along y-axis or x and y direction. So x and y directions are perpendicular to each other. So this resolution, that's why this resolution is called as rectangular resolution. So normally we are resolving a force along two perpendicular directions x and y. So in this example we have already discussed it. In this example, here in this figure, force F is acting at point O and theta is the angle made by force F with x-axis, and our problem is to resolve a force into its components acting along x and y direction. So here F is the magnitude of force, theta is its direction, and Fx is x component of the force. So Fx is equal to F cos of theta and Fy is equal to F sin theta. Fx is equal to F cos of theta and Fy is equal to F sin theta. So in this way, a force can be resolved along two perpendicular directions x and y. We have already discussed it and we have applied this method of resolution to find resultant of concurrent force system. So in this way, force can be resolved along two perpendicular directions x and y. Fx is equal to F cos theta, Fy is equal to F sin theta. Now after studying this rectangular resolution, now let us switch to skew resolution. Skew means two non-perpendicular directions. Two non-perpendicular directions are called as skew directions, and resolution of a force along two non-perpendicular directions is called as skew resolution. So now let us discuss about skew resolution. Here I have defined the meaning of skew resolution. Resolution along two non-perpendicular directions is called as skew resolution. So we are having a figure. Force F is acting at point O, and now our problem is resolve force F along two directions OA and OB. Now see, OA and OB, these are the two directions along which we have to resolve a force, and OA and OB are non-perpendicular directions. Here in this figure, theta 1 plus theta 2 is not equal to 90 degree. It means that OA and OB are non-perpendicular directions, and now we have to resolve a force F along these two non-perpendicular directions. This is not the case with first figure. In first figure, force F is resolved along x and y directions, two perpendicular directions. Fx is equal to F cos theta, Fy is equal to F sin theta. Now here we have to resolve this force along two non-perpendicular directions OA and OB. So theta 1 and theta 2, these are the angle between F and OA and F and OB respectively. So OA and OB are two non-perpendicular directions. Now how to resolve a force along two non-perpendicular directions? Now I have modified the figure. Again, this is the new figure, I have modified it. Force F is acting at point O. Force F is acting at point O, and these are the directions OA and OB, along these directions we have to resolve force F. Now let F1 be the component of force F acting along OA and F2 be the component of force acting along OB. So our problem is find F1 and F2. Find F1 and F2 if F is given, or resolve force F along OA and OB. So this is our problem. So in this figure, F1 and F2 are components of force F along two non-perpendicular directions OA and OB. Two non-perpendicular directions OA and OB. So here F1 and F2 can be obtained using these two equations. F1 is equal to F sine of theta 2 divided by sine of theta 1 plus 2, and F2 is equal to F into sine of theta 1 divided by sine of theta 1 plus theta 2. So using these two equations we can resolve a force F along two non-perpendicular directions. The figure is self-explanatory. F is the force which is to be resolved. F1 is component along OA, F2 is component along OB, theta 1 is angle between F and OA, theta 2 is angle between F and OB. And OA and OB, these are the two non-perpendicular directions, and hence the resolution is called as skew resolution. While in rectangular resolution, simply Fx is equal to F cos theta, Fy is equal to F sin theta can be used, and this is skew resolution. Here the directions are non-perpendicular. Now these two equations can be derived easily using triangle law of vector. Now here I am making one statement. F1 and F2 are components of F. It means that F can be replaced by F1 and F2, its components, or F1 and F2 can be combined into a single force F. And as discussed earlier, what is resultant? Resultant of two or more forces is a single force which has the same effect on a body as produced by two forces acting together or number of forces acting together. It means that we can replace F1 and F2 by a single force F, or F can be replaced by two forces. So composition and resolution. Resolution means dividing a force into its components. Composition means combining the components into a single force. So a force can be resolved along its components F1 and F2, or F1 and F2 can be combined into a single force, that force can be called as resultant. So here this single force is nothing but resultant of F1 and F2, or F1 and F2 are components of this single force. So here we will use triangle law to derive these two equations. How it can be used? For example, we are having two forces F1 and F2. F1 and F2. F1 is acting along OA, F2 is acting along OB. Okay, and this is the direction along which resultant is acting. This is theta 1, this is theta 2. Right? Now F1 and F2 are components of F, or F is resultant of F1 and F2. So in reverse direction, if I ask you to calculate resultant of F1 and F2 using triangle law, how one can proceed? So using triangle law, draw a line parallel to F1, and from the end of F1 draw a line parallel to F2, of course graphically. So this is F2. Then according to triangle law, the line joining the beginning of first force to the end of last force represents their resultant in magnitude and direction, and this resultant is nothing but F. Thus F1 and F2 are components of F, or F is resultant of F1 and F2. So this sentence is very important. Now in this figure, angle between F and F1, see F is acting along this direction, angle between F and F1 is theta 1. Angle between F1 and F2 is theta 1 plus theta 2, and angle between F2 and F is theta 2. So in this triangle, if you use sine rule, it can be written like this: F1 upon sine of the angle between remaining two forces. So F1 upon sine of theta 2 is equal to F2 upon sine of theta 1 is equal to F upon sine of Sine of theta 1 plus theta 2. Sine of theta 1 plus theta 2. This is the angle. This is direction of F1 and this angle is theta 1 plus theta 2, and here this angle is equal to pi minus theta 1 plus theta 2. Now if you write sine of 180 minus theta 1 plus theta 2, it will be equal to sine of theta 1 plus theta 2, or one can directly take this angle sine of theta 1 plus theta 2. So rearranging the equation for F1 and F2, we can write this like this: F1 is equal to F into sine of theta 2, F into sine of theta 2 divided by sine of theta 1 plus theta 2. Similarly, F2 is equal to F into sine of theta 1 divided by sine of theta 1 plus theta 2. So in this way, these two equations can be derived, or in this way, a force can be resolved along two non-perpendicular direction, and the resolution is called as skew resolution. Okay, so this is angle between F and F1 theta 1. This is angle between F2 and F theta 2. This is angle between F2 and F1 from this figure, theta 1 plus theta 2, and here the angle is written as pi minus theta 1 plus theta 2. And if you write here, F1 upon sine of theta 2 is equal to F2 upon sine of theta 1 is equal to F upon sine of 180 minus theta 1 plus theta 2. So it will be equal to sine of theta 1 plus theta 2, or here you can write 180, or directly you can take F upon sine of theta 1 plus theta 2. So in this way, a force can be resolved along two non-perpendicular directions, and this resolution is called as skew resolution. Now to apply this skew resolution, how to apply this skew resolution concept to a problem, that we will discuss. So first, I will write one statement on board, and then we will solve the problem. So these are the two equations to be used. I will not rub these equations. These are the two equations to be used. So the problem is two control rods. I am writing the statement: two control rods are attached at A to lever AB, comma, knowing that the force in the left hand rod is F1 is equal to 120 Newton. F1 is equal to 120 Newton, comma, determine. Now what we have to determine? Determine A. The force F2. The force F2. F1 is given, F2 in the right hand rod. In the right hand rod, if resultant R denoted by R is to be vertical, and hence find resultant. So this is our problem. Okay. So figure is given on a control rod at point A. Two forces are acting. This is F1 and this is F2. Figure is given 10 degrees, 28 degrees. So this is the given figure. Two control rods are attached at A to lever AB, knowing that the force in the left hand rod is F1 is equal to 120 Newton. Determine the force F2 if resultant is to be vertical, and also we have to calculate magnitude of the resultant. So here the given data first we should write. Given, what is given? F1 is given 120 Newton. F1 is given. We have to find F2, but F2 we have to find for the given condition if resultant is to be vertical. Find F2. This is part A. If R is vertical. So this condition is very important. When this such condition is given, then you should solve the problem using that condition. So this is nothing but hint given to you indirectly. If R is vertical, so use this condition and find solve the problem. Very simple. And in part B, we have to determine the corresponding magnitude of resultant. Now I will modify the figure. At point A, this is horizontal line through A. Two forces are acting, F1 and F2. So this is F1, this is F2. Right? Angle made by F2 with horizontal is given 10 degrees. This is vertical line. Okay, angle made by F1 with horizontal is given 28 degrees. And that's why angle made by F1 with vertical is 62 degrees. And angle made by F2 with vertical will be equal to 80 degrees. This is modification of the figure because here now I am going to apply skew resolution concept. And this is vertical direction. So in the problem it is mentioned F1 is equal to 120 Newton. Find F2 if resultant is vertical. So along this direction resultant is acting. And we know resultant it can be denoted by F, and thus F1 and F2 are components of resultant F1 and F2 are components of resultant R. Means F1 and F2 can be replaced by single force F, and that single force F is called as resultant. So indirectly here these are the components of force F, and these components are acting along two non-perpendicular directions. Thus we can use skew resolution. So our unknowns are, first we have to calculate F2 and then we have to calculate resultant R. Now according to our formula, we will modify the figure further. This is angle made by F1 with F, so this is theta 1. This is angle made by F2 with F, hence this is theta 2. Okay, and now using skew resolution concept, F1 is equal to F into sine of theta 2 divided by sine of theta 1 plus theta 2. So F1 is given 120 is equal to F unknown into sine of theta 2 sine of 80 divided by sine of theta 1 plus 2 62 plus 80 So only one unknown is there in the equation, and this unknown is nothing but F or resultant R, which is equal to 75.019 Newton. So in this way, skew resolution can be used to find the unknown or to find the resultant or to find the force F. Now let us calculate F2. We know F2 is equal to f sine of theta 1 divided by sine of theta 1 plus theta 2. Now f2 is the unknown, so f2 as it is. F is known to us 75.019 into sine of theta 1 is known to us 62 divided by sine of 62 plus 80, and that's only one unknown is there in the equation, and that unknown is nothing but force F2, and F2 is equal to 107.58 Newton. So in this way, concept of skew resolution can be used for this problem. Okay, so this is application of skew resolution formulae to solve a problem. Okay, the same problem can be solved using one more method, that is which we have already discussed, method of resolution. Okay, again using that method we have to use this condition if R is vertical. So we will be discussing the same problem by method of resolution during the next lecture, and we will be solving few more problems on skew resolution in the next lecture. Okay, so during the next lecture we will be solving few more problems on skew resolution, and we will apply method of resolution to calculate resultant of concurrent force system, and again under that we will be solving the same problem using method of resolution. Okay, so in skew resolution we have to use these two equations. And what is the difference between skew resolution and rectangular resolution? In skew resolution we are resolving a force along two non-perpendicular directions, while in rectangular resolution we are resolving a force along two perpendicular directions, normally x and y. In rectangular resolution, fx is equal to f cos theta, fy is equal to f sin theta, while in skew resolution we are using this equation to find the components. Remember, when you are resolving a force along its components, it means that you can replace that force by the components. Suppose you are resolving a force along x and y directions by two components fx and fy. It means that that given force can be replaced by these two components, or these two components can be combined into a single force F. This is the meaning of composition, and this is resolution. Resolution means dividing a force into components. Composition means combining the forces or the components into a single force F or resultant. Similarly here, a single force F is divided along two non-perpendicular directions F1 and F2, and these two forces can be combined into F, a single force, and that single force is nothing but resultant. So this is all about skew resolution. In the next lecture we will be solving few more problems on skew resolution. Thank you.